one is true, the other is less likely to be true. So the mind doesn't, the mind's making a whole bunch of different inferences, and something is going over them and working out which ones are coherent, and drawing together a coherent storyline of the scene. So this brings us to the frame problem. If you have a set of propositions and you start making inferences willy-nilly from those propositions, you end up with combinatorial explosion. However, this is how the mind works, and what the mind has to do, the human mind has an uncanny ability to work out what inferences are going to be relevant, which inferences are not going to be relevant. And to work out what's relevant is called the frame problem in the philosophy of the mind. And for the human being, the frame problem has been solved by evolution. So evolution has given us information processing systems which keep us in frame, right? So for example, Mary's fingernails are completely irrelevant unless they were previously drawn into context. However, the fact that Mary might be smart is always relevant because Mary is a sentient creature and we have information processing modules which are always automatically trying to associate personality characteristics with every sentient creature. So the frame problem is solved by evolution. So let's look a little bit further into sentient calculus and how it might work. So when we look at this picture, a stereotype concept of a line automatically becomes active, and then we create an instance of that stereotype for this particular line, and that instance inherits all the qualities of the stereotype. And then we start attributing personality traits to this instance. Now, as an aside, it's very hard to work with instances and categories with connectoplasm. However, they fall naturally out of traditional programming techniques. So the line character includes stuff, the line stereotypal character includes stuff like likes to hunt, and perhaps it likes to torture its prey before it eats it. And we use that information along with other information in the scene to start to construct a storyline about who this line is and predict the line's behavior in the future. And this is computationally feasible. If the mind is an information processing system, then it is computationally feasible to do this. We just have to solve the frame problem in the same way that evolution has solved the frame problem for us. So how might we do that? Well, we have to understand mentalese. We have to understand the innate propositions as they're represented in the mind, and then that will give us clues about how they're processed by the information modules of the mind. And there's really a lot done about this. There's so much done about this. And Dr. Len Talmy wrote a pivotal book in this field called Toward Cognitive Semantics. And Len Talmy is a cross-cultural cognitive linguist. And they look at all these different languages, the more the better, and they look at commonalities between the propositions. So if you can look at a whole bunch of different languages and you can find some universality between how the languages are working, then that might help us infer something about mentalese. So instead of giving you an overview of what's known about mentalese, I'm just going to drill down onto one topic. However, these two books are good places to start if you're interested in working out what's known about mentalese. The first book, Towards Cognitive Semantics, is a heavy academic work which gets right into the details. And the book on the left, The Stuff of Thought, is also an academic work. Sorry, what's that?
Book on the right.
The book on the right. And the book on that's right. And the book on the left, The Stuff of Thought, is also an academic work. It's very referenced. It's very well referenced, and it's very, very well written and easy to read, and it's a good introduction, and you can follow the references to go further into the topic. And the following discussion about causation and moral dilemmas comes from Steven Pinker's The Stuff of Thought. Okay, so Len Talmy, when he talks about causation in mentalese, he uses this term force dynamics. So I'm not going to use force dynamics because I think it's a bit of a confusing term, so I'm just going to refer to it as causation in mentalese. And what Len Talmy found is that when you look at all the causal constructs of all the languages of the world, all the ones that they've managed to study, you find that all the causal constructs of all those languages can be couched in 3 binary propositions. So first of all, there's an agonist which has a tendency towards emotional rest. Now, agonist is a common term in psychology. It's the antonym of antagonist. in causation and mentalese, the agonist is the causee. So we have an agonist with the tendency towards motion or rest, so it's a binary proposition. There's an antagonist which acts for or against the agonist, so that's a binary proposition. And then the antagonist wins or loses, so that's a binary proposition. So it's a 2 by 2 by 2 array. And all the causal constructs of all the languages can be represented in this 2 by 2 by 2 array. So for example, the street cat set the house alarm off. In this example, the house alarm is the agonist. It has a tendency towards rest. The house alarm is silent. And the street cat is the antagonist. It's going to act against the house alarm. And the antagonist wins. The street cat sets the house alarm off. So in contrast, causal Bayes nets are used in artificial intelligence research, and they're used to calculate probabilities that events will occur. So a causal Bayes net has a number of input variables. They're predetermined. Those input variables are weighted by probabilities, and computation is done from the input variables to work out the probability that your event's going to occur. So for example, the rooster crows could be an input variable, and from that you can calculate the probability that the sun's going to rise, because the crowing rooster doesn't cause the sun to rise from a human point of view. And you're also working with probabilities, because some roosters can be quite batty, and you can have roosters crowing at 2 o'clock in the morning and the sun's not going to rise. Now, the human version of causation is quite different. It's more complex to implement. Some computer scientists have been trying to implement it. I believe if you can implement this method of causation, you'll be able to make much more powerful inferences between antecedents, events, and consequences. And that will help you with developing better versions of machine learning. Okay, so this discussion comes from the Stuff of Thought in Pinker's book, and I think it quite clearly illustrates what's going on with mentalese causation and how we think about causation in physics. So in mentalese, there's a single entity that affects and impinges upon another entity. However, in physics, when two entities interact, neither entity has a privileged position in that interaction. In mentalese, the causee, or the agonist, has an inner impulse towards motion or rest. So if I have a ball in my hand, and I throw the ball in the air, when the ball leaves my hand, it has an inner impulse towards motion upwards. And as all inner impulses do, that inner impulse will wear out. And eventually gravity takes over and brings the ball down. However, in physics we know as soon as the ball leaves the hand, gravity is the only force which is working upon it. In mentalese, motion and rest are qualitatively distinctive states, whereas in physics, rest just means zero